So you got your first nuts and bolts down, statements and variables. That's great, but you got a lot more to go before we can turn you into a programmer. So let's keep rolling. Hey, if you hear you're coding with Paris, it's me, Paris. And this video is one of many videos I'm putting together called the Programmer's Nuts and Bolts. In this series of videos, what I'm trying to do is to teach you how to code as fast as possible by using the Pareto principle. That is, taking the top 20% of programming concepts that'll teach you 80% of what you need to know to start diving in. Anyway, in today's video, we're going to cover another nut and bolt called a function. Before we dive into today's content, go ahead and like and subscribe. Hit the bell notification if you want to get notified when I post a new video, and share this video with someone else who might be interested in programming. Also, if you have any questions, leave them in the comments section below. I'll try to get them answered for you. All right, let's go. Those statements and variables are important elements that you'll probably see in every single program. There's something else you might actually see in every program, and that is our new nut and bolt that we're going to learn about today, called functions. But before we dive into functions, let's try to introduce something we're going to call logic flow or flow control. Flow control is a way to describe how your code is going to be ran, what order your instructions are going to be performed in when you tell your computer to run your code. In the very simple examples that we followed before, our code was ran from top to bottom. And with logic flow, that is still the case. However, things become a little more complex as your programs start to become more complex. For understanding of logic flows, we're going to start attacking 3 different concepts. The first one that we're going to cover in this video is called functions, sometimes referred to as methods. What are functions? Think of functions as a way to divide your code into logical groupings of instructions. Basically a way to organize instructions in ways that make sense. Let's start by learning what the structure of functions look like, and then start breaking it down from there. So in your coding for Paris tutorial folder, go ahead and create a new folder. We'll call that lesson 3. So click outside of the folder, 3, and then underneath that, we'll add a new file and we'll call it functions.js. All right. Let's start with our first example function. This is an example of what functions look like in JavaScript. Usually you have a variable here, and that variable is going to be the name of your function, right? So give it a nice usable name, and usually it represents what the set of instructions inside are representing. Next, you have this word called function. This lets your computer know that you're going to build a function. You have the open and close parentheses, and we'll talk about what that means later. And then you have this open curly bracket and close curly bracket. And what goes inside? Those are your statements. And remember, we kind of talked about statements earlier before, and if you don't know what those are, just check out the earlier video called variables and statements, and we'll learn all about that. Functions differ from statements because they don't have semicolons at the end of them. They just end with a curly brace, and then the computer just knows that everything in between here belongs to that function. So all the statements in here belong to that function. All right, here we go. So here are some examples of what functions look like in a couple of other popular languages. We've got Java here. This is how Java creates a function. We'll ignore these first 2 words because they don't matter at this point, but this is how you name a function in Java, which is main here. This is the name of the function before the open paren and close paren. Again, looks very similar to the way we do things in JavaScript. We have the open bracket again. And then the code lies in between, right? The code that's waiting to be executed. This is what a function looks like in Python. And here you start a function this way, you name it. You got something letting the computer know that this is going to be a variable here. You give that function a name. There's that open and close parentheses again. Except this time Python has a colon, but then there's some code in between. Remember, Python, again, does not have semicolons at the end of lines. It uses indentions to know what belongs to the function. But This is an example of what a function looks like in Python, but notice that it looks very similar to JavaScript, okay? So let's talk a little bit about why functions exist in the first place. Again, functions are a way to logically group instructions together. They're usually more of an organization thing, and sometimes you can say it's probably more for others than yourself. But let's say you have a group of instructions that are meant to perform a calculation. Then you will bundle those together in something called a function. And like I said, it starts to make sense when your programs become larger and more complex. How do these functions fit into what we call logic flow? Let's look back at our first program, which we enhanced with the use of a variable, and how logic flows in that first. So in our first program, we created the variable salutation and we set that to hello world. And then we call console.log. Again, that's telling the computer to say what's in that function. If we were to look at the logic flow here, the program starts to run from here down. First, it sets up the variable in memory, and then it runs this next line here, and then we're done, top to bottom. Now, let's make it more complex by adding something called a function. We'll go with let greeting function equals function. Remember, we're giving the function a name and typing out the word function with an open paren and close paren, which indicates that we're creating a function. We create open bracket and a closed bracket, and those are curly. We'll type the text let salutation equals hello world, and then we'll say console.log salutation. It's very similar to our old program. Let's comment that out. Save what we have here. We'll open our terminal by going to the top of the window, clicking new terminal. Let's see where we are. We are in the Coding with Paris folder, so we'll go into lesson 3 folder by typing cd lesson 3, call directory lesson 3, and you'll see we have our functions.js folder. So now we'll run our code here by calling node and then call the name of our code here. I type part of it and hit tab and it finished it typing for me. Another cool feature of a code editor. Hit enter and you'll see nothing happened. Why did nothing happen? Well, you see, in this case, the program started to run, and it did indeed run, but the only thing it did here was it saw our setup of this function. To actually run a function, you need an additional piece of code, and we'll go ahead and add that here. You actually make the program run the function by typing the following. So let's save. Come down here, press the up arrow key. It will run the last command that you gave it in the terminal. Hit enter, and you'll see we print hello world here. So what happened? This program, if it's running from top to bottom, and actually set up the variable of your function here, and then later on in your code, you told it to call that function, and you see the open and curly bracket there, which then made the program go back here and run what was in between those open and closed brackets. And when it was done, the execution was completed. One thing I want to note about functions is that they must be defined before they are called. So I could not take the same piece of code and run it this way, because you would get an error, can't access greeting function before initialization. So this is JavaScript way of trying to tell you that you have to initialize the function, you have to set the function before you can start calling it. Let's talk about inputs. You can enhance functions with something called inputs. I'll give you an example of what that looks like, and then we can talk through it. So let's create another function. We'll call it some function with input. Create a new function this way. Follow along. Remember, the more you type something, the more it sticks. The more you struggle with something, the more it sticks. So you'll see what I'm doing here is putting values inside of those open and close parens. Here, some text. So what's going on here? Well, now we're looking at our function called some function with input here, and we can see that this has two values here. One that says some variable number 1 and one some variables 2 inside of the open paren and close paren. These two things are called inputs. What are inputs? Well, inputs are ways you can feed your function values to do stuff. Simple as that. Think of inputs as variables that you can define with the definition of your function that you can call with inside of your function as well. Now remember, these variable names must make sense if you're going to use them as your function pieces. So give them names that make sense to what this function is supposed to be performing and what those variables represent. In this example, we are telling the console to log or to print out what variable 1 and variable 2 means. So let's go ahead and try to call this function here. And we do that again by following the definition of this, the initiation of this function with the function name, close bracket. We'll go down here, we'll clear our console by typing clear. And then we'll hit our up arrow key twice. That will give us to this command here, and we'll press enter. Now notice that what gets printed here is undefined, undefined. Do you guys remember what undefined means? Yes. If you've guessed, the console is actually logging what's in this function because we called the function here, the execution went here and ran this and gave us undefined, undefined, because these two input variables that we set here were not called. So let's go ahead and give this function two values. Let's say some text 1 and some text 2. We'll save that. We'll hit the up arrow key again down in our terminal. We hit enter, and you'll see here that now, since we called this function with this variable, this value here and this value here, we get the following text printed. Some text 1 and some text 2. So this is how calling a function with input values work. We plant values into the variables that we set up here at the beginning, and then we reference those variables here in the program, and you get results just like that. So remember, in functions, you can do as many statements as you want in here. This is just a really simple example. So we'll comment this out here. So we'll take our first program and we'll enhance it one more time, now as a function with inputs. Getting function equals function. Okay, and this time we'll take first name, last name. And we'll go. Name, last name. And then we'll come down below and we'll call that greeting function again. You just call it, and we'll give it an input of Paris, comma, hair. Now, another thing to note about parameters is that you must feed them the parameters in this same order, right? So first name is going to align with first name, last name is going to align with last name. So we'll add our paran, we'll come down here, and we'll run this code. Uh-oh. Think we forgot something here. Uh-oh. We forgot our quotes here. We must wrap our strings in quotes, ladies and gentlemen. Now let's go down and run our code. And now the greeting function provides us with Paris hair. The logic flow of this is we set up our function again, right? We call our function with the inputs of Paris hair, which makes the code go back up and execute what's in between this function, this greeting function here, which is telling the computer to say my first name, or at least the first parameter here, and the second parameter next. Hence the result. Okay. There's something else you need to know about inputs, and that is we can give inputs default values. So let's take a copy of this function here, comment it out, and come below it, paste that function, but instead of providing Paris hair, we actually come here and say Paris hair here. We save our code and we come down here and we run the function. So I'm not given this function inputs, but when I run this code, it says Paris hair below. What's happening here? Well, we gave this function default values for these inputs. Default values are used when you don't provide inputs. So let's take a note here. Let's take a note that, right? But then let's duplicate that line and let's give it some inputs again. Han Solo right? Han Solo is printed the second time. Because we gave this input the values, it will not print. Let's do one more thing here to nail it home, right? And we'll do, so undefined here is saying we're not passing anything in. You recognize this. This is nothing that represents nothing being set, right? Null is different. And let's see what happens here. The third one is Paris Solo. I think we've nailed the default value thing home. So let's move on, huh? Let's talk about the next important piece to functions. Return statements. And now we get to the beauty behind functions. So not only can we give functions input values, but guess what? We can get output values. Our functions can be treated as vending machines. And this is where we start getting into why code can be reusable. Let me give you an example of a function that contains what we call the return statement, and then we'll explain what's going on. Follow along, students. Let's say something funny about function. We're given an input called subject, and we'll default it to blonde, and then we'll return so a brunette, a redhead, and a subject. bar. Okay, so what's going on in this function here? Well, we're creating our function called say something funny about. We're giving it a variable with a default, but then we have this keyword return here. And what's following it here is a bunch of text. What's happening here is that if we came down and we ran this function without providing any values because we had a default, nothing would happen. Wait a minute. Why not? Well, first of all, because we're not telling the computer to say what's in here, right? We're just telling the computer to return what's in here. And this is where we learn about what return statements do, okay? So let's instead add to this and say, let joke equal this, okay? And then we say console.log joke. We'll save, go down to our terminal and run this function. Now what happens is we get this text here. So a brunette, a redhead, and a blonde walk into the bar. What happened here? Well, this return statement gave this result that we just put together here back to this variable. When we called it here, it's returned to this variable, to which the program continued and told the joke because of this console.log statement. Am I confusing you yet? So let's talk about the logic flow. This function is created. This next line told the computer to set this variable equal to the result of running this function, which came here, and return the result of that function, return, using that return statement, back to this variable, to which the very next line here, console.log, made the computer say the joke. And you get this result. That's logic flow for you. Again, it is going from top to bottom, but it becomes more complex because this function is now introduced. And so when we call the function here, it actually goes back, executes that function, and then continues to line 67, 68, 69, and so on and so on. Now, some of you might have noticed this weird thing about return statements is we have return and then some things after it, and it has a semicolon. You need the semicolon. You can also, for visibility reasons, add whatever you want to be returned to open and close parentheses in JavaScript. All computer languages have the concept of inputs and returns, and they play a very important role in making functions useful in programming as well. There's something important that I need to share with you about a function that has a return statement, and that is no statements after a return statement on a function can be ran. And I'll give you an example of that. Let's say we have a function here and we'll call it fake function, and inside of it we're telling that function to do something, and then we're telling that function to return when it's done. Okay, return this text here. Okay, so let's go down and call this fake function. The only thing that happened was it said in the function. Why that happened? Because again, we set up the function, right? We called the function, which made the computer come back up to this function. It logged in the function. It returned something, but I actually didn't capture it into a variable. So let's do that. Let result equals fake function here. And then we'll do console.log result. And now we have in the function, done with the function. But notice we are not logging this phrase, wait. And the reason is because the way the logic flows here is that once the function sees this return statement, it's assuming that it's done with all execution inside of this function. It will jump out of this function, back into the main line without actually continuing anything afterwards. And you'll see that my IDE is trying to warn me about this by making this statement a little bit lighter. So it's warning me that, hey, this is unreachable. If I mouse over it, it will let me know, and even offers suggestions on how to fix it. That's that artificial intelligence for you. But it's just letting you know that this is not going to work. Okay, so remember, anything after a return statement is dead code. It will not work. It will save, it will run, the program will run, but that code will not run. Will not run. Okay. All right, so now we're going to nail down logic flow and our new knowledge about functions by creating a larger program together. Okay, so for this code example, what we're going to do is we're going to create a program that takes two numbers and it performs a bunch of calculations with them. Very simple calculations. First is going to add them together, and then it's going to take one and subtract it from the other, and then it's going to multiply the two numbers together, and finally it's going to take the first number divided by the second number, and it's going to print all those results in our terminal below. You ready for this? Okay, let's go. Follow along, students. Let take two numbers equals a function that's going to take two parameters or inputs, number 1, number 2. Okay, and the first thing it's going to do is add the numbers together. Let's try that. So what we'll do here is we'll create a function above this one. Let's go ahead and say let add function. And let's take the two numbers as input. Number 1, number 2. Create open and close bracket. Oh, forgive me. You might have noticed I forgot how to set up a function. Okay, so we are going to now take number. We're going to return the result again. And we're going to return number 1 plus, find the plus sign on your keyboard, number 2. Okay, this function here called take two numbers is the one that we're going to run. And so we're going to make this function actually take the result and print the results out. So we're going to come back to that function here, and we're going to say add let sum equals add function, and we'll take number 1 and number 2 again. Okay, so from these inputs here, number 1, number 2 here, and then we're gonna go console.log, and I'm going to use this quote because this actually allows us to create multi-line quotes or multi-line strings here right in our code. So just copy me for now, and we'll come back to what the heck that means later. So in between here, we'll say sum equals sum, and then we'll come down and run our code just to make sure we know what's going on. All right, so we'll just say printing things here. All right, so let's call this function take two numbers, and we'll put 1 and 1. Okay, come down, clear our terminal, and because we've commented everything up above, we can just run our code, and voila, we get sum equals 2. All right, let's slow down for a minute and go back and talk about what happened. Okay, so logic flow. When we run this program, the logic flow starts from top and goes to the bottom, like so. And yes, we created a function called add function here. And then we created a function called take two numbers here. And we ran that function with two inputs, 1 and 1. That's the way the logic is flowing. Let's break it down a little bit more. So, though we created those two functions, we called this function here with 1 and 1. The logic swings back to call take two numbers. And the very first statement inside says, hey, I want you to call the add function with the two numbers that I gave you. Remember, 1 and 1. So then it calls this function with 1 and 1. It returns the sum, which is number 1 plus number 2, back to this result. And then it prints that result out here. Hence we get that. Is your brain hurting yet? Let's continue on our mission. Next, let's subtract these numbers. So I'm going to do a little bit different here in a little bit different order to see if it makes sense to you. Your style is your style. You can do this either way. Sometimes I like to define the function in the main line that I want to use and then create it, or you can go the other way around. So let's do it this way. So we'll take the difference of the numbers equals subtract function. And again, we're going to feed it number 1 and number 2 in that order. Okay. And you'll see my IDE is kind of making this pale because this doesn't exist and I'm calling it, right? And remember, in order to actually call something, it must be defined. So again, this has to be defined up here above this function. I know, a little strange. Stick with me. Let subtract function. We'll give it the number 1 and number 2 as inputs. And we're not going to put defaults in here because we want this function to be fed numbers from the thing that's calling it, okay? So, again, got to remember how to set up a function, right? Space. And we'll return number 1, subtract number 2, the difference, okay? And now we'll actually come here and we'll press enter and we'll say difference equals $, curly bracket, difference. Now we'll save our code, we'll come down here, we'll press the up arrow key and run our program, and guess what happens? Now we have sum equals 2 and difference equals 0 with these two numbers. We go over what happened again? I'm taking a sip of coffee. Let's go over what happened again. So our logic flow starts at the top. It creates this function, creates this function, creates this function, right? And then comes down to this line of code, which actually tells it to run, take two numbers with the input of 1, 1. The very first statement in take two numbers calls the add function, which again comes here, adds the numbers 1 and number 2 together, captures that as a variable called the sum. The next thing it does is it tells the program to run the difference by running the subtract function. So again, it comes up, runs this and takes number 1, subtract number 1, right? That's the input we give it here and here and here and here. And then it sets the values there. Finally, it takes these two variables, calls console.log, and this multi-line string here is printing it out. And by the way, the reason why we're doing multi-line strings is that I can actually press the enter key in between each line and it will keep that line and print things accordingly down here, which is how you get this nice little sum difference here. And you know, I am forgetting and if anyone might have noticed, I am forgetting my end semicolon, but that's okay. This thing is forgiving me for that. So once the execution ends here, then we're at the end of the code here. Should we go on? Brain hurts yet? We got 2 more to go. Now let's go to let product equals multiply function. And we'll pass in those same numbers here. We'll just keep referencing those, right? So number 1 and number 2. And of course, if I were to run this, it would explode because I haven't created this function yet. So, and I can't create it underneath here because you can't call something before it's actually set up. So let multiply function, hey, thank you IDE, take number, oops, let's not do that again, equals function number 1, number 2, and we'll take the result of that, number 1 times, this is how you multiply, number 2. That's how you multiply two numbers in JavaScript. And then we'll come down here and you guessed it, we'll say the product equals $, the product. And then we'll save our work, we'll come down, see, 1 times 1 equals 1. It's looking correct so far. Do I need to explain what happened? Nah, we'll add our final piece of code here. Let quotient equals divide function. And we'll take that number 1, number 2, put that semicolon there. And we'll come up here and we'll say let divide function equals function number 1, number 2, keep up, return number 1 divided by number 2. And we'll come down here and we'll say the quotient equals the quotient variable here. All right, let's save our work and run this code again, and you'll see that 1 divided by 1 is 1. Folks, we have completed our mission. We've created our first multi-line program. I want you guys to stare at this and try to understand how the logic is flowing between these various functions. And I want you to notice this pattern and remember this pattern here of having a main function, right? A main function that's performing all of our actions by calling the various pieces of code. A lot of code looks like this, okay? So get used to writing things this way. You know, you set things up and then you logically organize things into functions that make sense together. Each one of these are doing a calculation, for example. Obviously, you can get more complex with calculations. So you have an input, you have an output, which you're capturing here in variables, and then you're doing something with those variables a little bit later in your function. In this case, you're just writing them out in a way that makes sense in a little report in your terminal. My gosh, if you've done this, you are literally becoming more and more of a programmer. Good job. If we were to go back to our animation to simplify things, we can see that every time we run our program, it starts from the top and goes to the bottom, right? It starts from the beginning of the program, runs the instructions from top to bottom. Let's talk about how functions fit into this picture. Now, when we add a function to our programs, we usually do it within that gray arrow that's flowing from top to bottom. But when we call our function, it's represented by this blue dot. That blue dot represents when we call our function with inputs, if they're required, the logic is ran, and then it returns back to that gray line and flows downward. The logic flow continues that downward path. Here's an example of what's going on when multiple functions are called. Remember, when functions are defined, they're not actually running, and they're defined within the gray arrow, maybe at the top or maybe right before they're called here, in between, the little gray bars in between. But the way the logic flows is that you call the function, it runs the logic within that function, and then it continues on in the program, like what happens after function 4 is called. All right, my coders, let's talk about what we learned today. So first of all, we enhance our nuts and bolts tool belt by talking about something called logic flow. And logic flow is important to know because it literally refers to the way that programs run, the way that code runs, which is usually from top to bottom physically in the file that you're looking at. However, we learned that more complex programs actually do a little bit more bouncing around, and so it's important to understand the way the logic usually flows in the program. And then we took our nuts and bolts about logic flow a step further by explaining the very first pattern or the very first piece of logic flow, which there are more, but we talked about the very first piece, which is functions. We talked about how functions are organization of statements, both visibly and logically, and how the functions are set up. Basically, you have to name your function, use the keyword function in JavaScript, and you give that function inputs if necessary, and you can reference those inputs inside of your function if need be. You can give those inputs default values if need be, and your function can actually return a value, kind of an input-output thing, which makes functions a very good utility to use in your tool belt. We talked about how nothing can be executed after the return statement of a function, and we talked about how the return statement gives the value of the function back to the caller, which they can store as a variable and use later on, like we did earlier in the code. Finally, we wrap things up by creating a program. It takes two numbers and does 4 calculations and prints a nice little report in the console for folks to read. My gosh, I don't know what to say except this is very exciting. You guys are now starting to become fully fledged programmers, coders, whatever. But let's not stop here. We have some more things we need to tackle on logic flow. So I'll see you in the next video. Peace.